Welcome to the Crazy Hack Chemist. So another video on bonding and molecular structure. So let's get moving. Bam! So we're going to be doing ammonia's molecular structure and molecular geometry and so much more. So what is the formula for ammonia? Everybody knows it. It's NH3. Okay, so we're going to look on our periodic table, get the number of valence electrons for nitrogen and for hydrogen. For nitrogen, it's 5. There's 1 nitrogen. For hydrogen, it's 1. There are 3 of those. We're going to sum these numbers up. Then we're going to get the total number of electrons, which is 8. We're going to divide that by 2. Then we're going to get 4 pairs of electrons. Now, the least electronegative element goes in the middle, but never hydrogen. Therefore, the nitrogen goes right smack in the middle. Okay, now I'm going to spread the hydrogens around the nitrogen as like thus. Now, I'm going to follow the rules, okay, of electrons. That is, I'm going to place these 4 pairs of electrons. So I'm going to dump in bonding pairs of electrons in between the central and the outside elements. That is done just right there like that. Now, the question is, hydrogen follows the duet rule, so that's already been satisfied. So because of this, then the next set of rules here is to place electrons on the outside elements. But I can't do that with hydrogen because hydrogen follows the duet rule. So I'm going to not do that rule, and I'm going to do the next rule. And the next rule is to place pairs of electrons on the central element. And that is right here for the nitrogen because it is electron deficient. That means it is currently electron deficient, but it is in period 2, and it must obey the octet rule. Okay, and therefore I'm going to dump that extra pair of electrons right there on the nitrogen. This is a lone pair of electrons. Okay, and that verifies the octet rule for nitrogen and the duet rule for hydrogen. I'm going to tidy this up, make it look really nice and pretty. Bonding pairs of electrons are lines, and lone pairs, even on the central element or on the outside element, are still dots. So here is what our Lewis dot structure should look like for ammonia. Okay, now from this, I'm going to do the X. Okay, everybody knows the X. The A is the central element. That's the nitrogen. How many X's do I have? Those are the hydrogens on the outside. I've got 3 of those. How many E's on the central element? That's 1. So I should have AX3E. That is what I have. And then from the bonding and non-bonding domains around the central element, I've got 3 bonding domains and 1 non-bonding domain. From either the AX3E or the 3 bonding and 1 non-bonding, I should have the following. And that is, bam, trigonal pyramidal. So everybody should be getting trigonal pyramidal for that structure. Trigonal pyramidal has a bond angle that's less than 109.5. In the case of ammonia, it is 107 degrees. I'm going to count up here around this to get the hybridization. So this is S, P1, P2, P3. So that's sp3 hybridized. Now I'm going to look at this and figure out, is this polar or non-polar? Okay, and here is the shape here. Okay, here is the molecule, the structure of NH3. I'm holding on to the lone pair of electrons. Are you going to ask yourself, does this have polar bonds? Absolutely. The nitrogen is certainly more polar than the hydrogen. Therefore, the arrows are going towards from the hydrogens to the nitrogen, and then there's an arrow going away from this lone pair of electrons here. So that would be that this is has polar bonds, and it is asymmetrical. Therefore, this molecule here is polar. Ammonia is polar. Okay, hopefully that worked out well for you. That's a super cool video. Okay, give me a thumbs up if you like that. Subscribe to my YouTube channel, please. And because I'm bare about that. See you next time. Bye now.